My name is Dawson Douglas. I'm with Group 3, and I'm the reporter for this week. I'll be presenting the results for Experiment 4, the jet engine experiment. To refresh the procedure for this experiment, before you start, you'll check the area. You'll make sure you'll have right PPE, so long pants, safety glasses, and ear protection since the jet engine gets pretty loud. To start the operation, there's a keyed start and there's a green start button. There'll be two levers. One is pinned and it will adjust the load, and the other adjusts the throttle. And to turn off the jet engine, there's a red stop button. The data will be collected through the TurboGen software provided on the laptop. So state 1 of the jet engine is the compressor inlet, and on the left is the compressor inlet temperature running throughout the experiment, and on the right is the compressor inlet pressure running throughout the experiment. State 2 is the compressor outlet, and on the left is the temperature versus time, and on the right is the pressure versus time. State 3 is the turbine 1 inlet temperature, and on the left is the temperature graph, and on the right is the pressure graph. State 4 is the turbine 1 outlet with the temperature on the left and pressure on the right. And state 5 is the turbine 2 outlet with temperature on the left and the pressure on the right. You'll also have fuel flow that goes on throughout this experiment as the jet engine takes in fuel, and the engine RPM will also be taken into account. You'll also take into account the generator RPM and the generator voltage. The generator current and generator power will also be in the data. So for the system analysis of the jet engine, you pick a point, or I picked a point that was at the peak of the engine RPM throughout the experiment, which was at time 560 seconds. And I calculated the compressor inlet to be 300.4 kilojoules per kilogram, or the enthalpies at the compressor inlet to be 300.4, at the compressor outlet to be 38 kilograms per kilojoule, at the turbine 1 inlet 996.3 kilojoules per kilogram, at the turbine 1 outlet 924.5 kilojoules per kilogram, and at the turbine 2 outlet 725.7 kilojoules per kilogram. All of these were calculated using the air tables from the thermo textbook. For the process done throughout the compressor, the specific work was calculated to be 77.4 kilojoules per kilogram. The energy added from states 2 to 3 was 618.5 kilojoules per kilogram. The specific work done by the first turbine was minus 71.81 kilojoules per kilogram. The specific work done by the free turbine was minus 198.7 kilojoules per kilogram. And the specific work done by the entire cycle was 347.9 kilojoules per kilogram. And the thermodynamic efficiency of the cycle was calculated to be 56%. For the engine performance analysis, the recorded static pressure at the inlet to the compressor was 2.57 kilopascals. The density of air was 1.225 kilograms per meter cubed. The mass flow rate of air in the compressor was 0.06 kilograms per second. Volumetric flow rate was calculated to be 0.0497 meters cubed per second, and the Mach number was calculated to be 0.224. For the electrical generation performance analysis, we took measurements while the load lever was pinned, which was at 698.9 seconds, and the speed ratio was calculated through the RPM of the first and second turbines, and that was calculated to be 20.3. The voltage output for the generator was 5.18 volts, with the current being 38.3 amps. And using those, we calculated the resistive element to be 0.135 ohms. The power output was 344.5 watts, and the power specific fuel consumption was 0.136 kilograms per kilowatt hour. While the load lever was unpinned at maximum excitation, which meant there was the heaviest load, so the current was at its lowest, which was done at 755 seconds. Speed ratio was 50, voltage was 3.34 volts, current was 24 amps. The resistive element was the same as before at 0.135 ohms. The power was 143.24 watts, and the power specific fuel consumption was 1.7 times 10 to the minus 5 kilogram per kilowatt hour. And while the load lever was unpinned at minimum excitation, the speed ratio was roughly 7, the voltage was 8.9, the current was 6.6 amps, or 66.6 amps. The resistive element was 0.135 ohms. The power output was 1,037 watts, and the power specific fuel consumption was 8.267 kilogram per kilowatt hour. These are my sample calculations. Some more. I used the jet engine lab manual and the thermodynamics textbook. Any questions?